Hello everyone, welcome to Solely Science. In today's video, we will see some of the sums from the chapter Effects of Electric Current of class 10th. The question goes like this. A 6-meter long wire made from alloy nichrome is shaped into a coil and given for producing heat. It has resistance of 24 ohms. Can we get more heat if the wire is cut into half of its original length and shaped into a coil? For getting energy, two ends of the wire are connected to source with potential difference of 220 volts. So first, whenever you will have to solve a problem in science, then first write the given values which are present in the question. So we have resistance to be equal to 24 ohms. The length is given as 6 meter, and the next thing is the potential difference, that is given as 220 volts. The question is, can we get more heat if wire is cut into half of its original length and shaped into a coil? So first we will find the power when the wire is not cut into, first we will find the power when the wire is of its original length. So we have power is equal to V square upon R. The V value is, we also have power is equal to V into I, and the other formula is V square upon R. Since here we don't have any values of current, so we will use this formula, that is power is equal to V square upon R. We have voltage 220 volts upon resistance is 24. So on solving this, we will get the power as 201 watts. Alright, in the next part of the question, we are reducing the length of the wire by cutting it into half. So if the wire is cut into half of its original length, then the resistance value will also drop by half. Here we had 24 ohms resistance, so now the resistance will be 12 ohms only. So again the same process, power is equal to V square upon R. We have voltage as 220 volts upon R is 12. So upon solving this, you will have the power is equal to 403 watts. So initially in the original length we get power as 201, and when the length was reduced, then we got the power as 403 watts. So we can conclude that more heat will be obtained after cutting the wire into half. So this completes this numerical. Now we will see another sum of the same chapter. Let me quickly write down the question first. So here is the question, and let me read it. A cell is connected to 9 ohm resistance, due to which heat of 400 joule is produced per second since electric current is flowing through it. Again, this is the phenomenon of heating effect of electric current. We have to find the value of potential difference applied across the resistance. So this is a easy numerical. First of all, we have the resistance to be equal to 9 ohm. The heat energy produced is given as 400 joules per second, and we have to find the potential difference which is applied across the resistance. Alright, we know power is equal to energy required upon the time taken, so we can write it as 400 joules upon 1 second. So we have the power as 400 joules per second. Here are a few formulas of power that you need to remember. First is power is equal to V into I, and the second one is power is equal to V square upon R. Since again we don't have any values of the current, so we will go with this formula. We have power is equal to V square upon R. What we need to find? V here. So we can write V square is equal to power into R. What is power? 400 joules. Resistance is 9 ohm. So V square is equal to 400 into 9. We can write this as under root of 400 into 9. That will be equal to 20 into 3. that will be equal to 60. Therefore, the potential difference which is applied across the resistor is of 60 volts. Alright guys, now we are on the third sum. The question is, iron uses power of 1100 watts when set to higher temperature. If it's set to lower temperature, then it uses power of 330 watts. Find out the electric current and resistance for two settings. Iron is connected to a potential difference of 220 volts. First of all, we will write down all the given data. So given is power 1 is given as 1100 watts, power 2 is given as 330 watts, the potential difference or the voltage is given as 220 volts. We need to find the value of resistance R1 and resistance R2. And even the values of current. We find out the electric current and resistance for two settings. So we need to find R1, R2 and also I1 and I2 for these two powers. We have the formula power is equal to V into I, that is voltage into current. So for I1 it will be equal to P upon V1, P1 upon V1. V1 and V2 is equal to 220 volts only. And power 1 is 1100, so substitute here 1100 upon 220. So it is 5 ampere. Therefore, I1 is equal to 5 ampere. Then for power 2, same formula, P is equal to V into I. So P2 will be equal to V2 I2. Therefore, I2 will be equal to P2 upon V. Power 2 is 330. So we have 330 upon 220. That equals to 1.5 amperes. Therefore, I2 we got as 1.5 amperes. Now we have the value of voltage, we have the value of current, we need to find resistance. So Ohm's law, V equals to IR. For R1 it will be equal to V upon I1 and for R2 it will be equal to V upon I2. V is 220 upon I1 we got as 5 amperes. So this will be equal to 44 ohms. So we got R1 as 44 ohms. Similarly, we will do for R2. V equals to IR, so R2 will be equal to V upon I2. V is 220 volts and I2 is 1.5 amperes. Here it is. So we will, on solving this, we will get 146 ohms. So the R2 value is 146 ohms. This completes this numerical. Now moving ahead with the next one. So here we are on the last sum. The question is, an electric tungsten bulb is connected into a home circuit. The home electric supply runs at 220 volts potential difference. When switched on, a current of 0.45 amperes flows through the bulb. What must be the power of the bulb? And if it's kept on for 10 hours, how many units of electricity will be consumed? First we will write the given data. So we have potential difference given as 220 volts. The current is 0.45 amperes. We need to find the power and what will be the units consumed when it will be used for 10 hours. Okay, so now moving to the solution, we have the formula power is equal to V into I. We have the value of voltage and the current as well. So substitute it 220 into 0.45. We will have the power equals to 99 watts. Now we need to find if the bulb is kept on for 10 hours, how many units of electricity will be consumed. Now for this, all you need to do is multiply 99 by 10. So 99 into 10 hours give you 990 and this can be written as 0.99. So with this we come to the end of the video. I hope you understood all these numericals. These are obviously important for exams, so don't think about skipping it. Thank you so much for watching till the end, and do subscribe to Solely Science. Thank you.